In the last video, we talked about 30, 60, 90 triangles and using those special triangle relationships to figure out all the different side lengths and solve 30, 60, 90 triangles. In this video, we're going to deal with 45, 45, 90s. So what I like to do whenever I see anything involving 45, 45, 90s is basically sketch an isosceles triangle with two 45-degree angles, and the pattern that goes with 45, 45, 90s is 1, 1, radical 2. The side length times radical 2 is the hypotenuse. Hypotenuse divided by radical 2 gives me the side length. And then these two angles are going to be congruent. These two sides are going to be congruent. So let's see what we got. So for number 1 here, find the value of x in each triangle. We want to find the hypotenuse. The side times radical 2 is the hypotenuse. So 8 radical 2 is going to be x for number 1. Number 2, they're telling us that a leg is 14. So the other leg is going to be 14 since it's isosceles. And 14 radical 2 is going to be the hypotenuse. Number 3, see what we got. They're giving us a side. Now, this square is bisected in area by this diagonal, and we have two congruent triangles set up. The diagonal of a rhombus, which a square is, diagonals bisect each other, and diagonals also bisect the vertex angles, or the corners of the square. So this is a 45, and this is a 45. So in effect, what we have is a 45, 45, 90 triangle with a side length of 18. So 18 times radical 2 is going to be the length of the diagonal, which is the hypotenuse of this small triangle. So that's where our x is at. Let's look at number 4. They're giving us the hypotenuse. This is an isosceles right triangle, which means it's a 45, 45, 90. Angles opposite congruent sides are congruent, base angles theorem. So the short side times radical 2 comes out to be 18. So I have to divide 18 by radical 2 and simplify. We get 18 radical 2 over 2, which is 9 radical 2. The side lengths must be 9 radical 2. And you can check it out, like if you do 9 radical 2 times radical 2, you have 9 radical 4. Radical 4 is 2. 9 times 2 does give you the 18. So you can kind of mentally check it out and make sure you're using the right ratios here. Number 5, okay, one 45-degree angle is enough to cause all the angles to be 45 degrees. If the hypotenuse is 8, the short side, x could be over there too, times radical 2 came out to be 8. So to see what the short side was, I need to divide radical 2 out, rationalize it. We got 8 radical 2 over 2, which is 4 radical 2. Short side, or x, is 4 radical 2 for each one of those. Number 6, another square with a diagonal. Therefore, these are two 45, 45, 90 triangles. Just dealing with this top one here, we have a 45, 45, 90 with a hypotenuse of 10. The short side times radical 2, short side times radical 2 comes out to be the hypotenuse. So we got to do the inverse operation. We have to divide radical 2 out of 10. 10 divided by radical 2 is going to give us 10 radical 2 over 2, which gives us 5 radical 2. So this x must be 5 radical 2. And again, if you check it, 5 radical 2 times radical 2 is 5 radical 4. Radical 4 is 2. 5 times 2 does give you the 10, so it checks. Let's look at number 7. The perimeter of a square is 48 meters. So a square has 4 congruent sides. So if the perimeter is 48 square meters, if I divide 48 by 4, I get 12. 12 meters is each side of this square. I'll just mark it as a square. find the length of the diagonal. So if I draw the diagonal here, now square is a rhombus, which means that the diagonal bisects the 90-degree angles, and that gives us a 45, 45, 90 with a side length of 12. 12 radical 2 is going to be the hypotenuse, which is the length of the diagonal of this square. So 12 radical 2 is going to be the diagonal that they're looking for this one. Okay, numbers 8. The perimeter of a square is 20. Oh, this is in meters. They're giving us units, so you have to have meters. Perimeter of a square is 20. So 4 equal sides, 4 times 5 makes 20. And we want the length of the diagonal again. This is just like the one above, except the numbers are different. And this is going to be 5 times radical 2 in terms of centimeters. So 5 radical 2 centimeters is going to be the length of the diagonal. Again, it's 1, 1 radical 2, 5, 5, 5 radical 2. For the ones at the bottom here, we want to find x and y both. So let's see what we got. If now in an isosceles triangle, these are going to be congruent to each other. So x is going to equal y for this one. So if 7 is the hypotenuse, the short side times radical 2 made 7. So 7 divided by radical 2, which is 7 radical 2 over 2, is the hypotenuse length, or is the short side length. So x and y both are 7 radical 2. For 10, isosceles triangle, they're giving us a side. The other side is congruent. And the short side times radical 2, 10 radical 2, gives us the y. Number 11 gives us a side. The other side is 7. 7 radical 2 is going to be the hypotenuse. 1, 1 radical 2 again. Okay, here they're throwing 30, 60, 90s at us. Okay, so we got to go back to our 30, 60, 90 triangle. So right away, I'm going to just sketch a 30, 60, 90 for reference. And when you do these enough times, you just basically get them memorized. But the pattern with a 30, 60, 90 is 1 radical 3, 2. And again, the pattern for 45, 45, 90 is 1, 1 radical 2. So these are the two basic ones that you need to be able to sketch whenever you need to do these, if you don't have everything memorized. So the short side is x. X doubled is y. X times radical 3 is 20. To find out what x is, I got to do 20 divided by radical 3. So 20 over radical 3, rationalize it, get 20 radical 3 over 3. And that's the short side, 20 radical 3 over 3. Now double the short side is going to be the hypotenuse. That's going to be 40 radical 3 over 3. So that's how we can find those two pretty quickly from the ratios. 13, the hypotenuse is given to us. We got a 30, 60, 90. The hypotenuse is twice the short side. So if I do 20 divided by 2, I'm going to know what x is. That's going to be 10. And then the short side times radical 3 gives me the side opposite the 60. That's going to be 10 radical 3. So those are the side lengths that go with that. Last one here, number 14. They're giving us the short side. If this is the 60, this is the 30. That makes this the short side. Short side doubled is the hypotenuse. Short side times radical 3 is the side opposite the 60. Okay, so in this video we've tried to focus on 45, 45, 90s. There's another companion video that deals with the 30, 60, 90 patterns. These are the key triangles that you need to be able to sketch at a moment's notice to use as a reference. Okay, thank you for watching. Let me know if there's anything else that you'd like to see.